Okay, so chapter 4, I'm on page 155 in the book. And by the way, the book with the answers or the chapter with the answers is posted, so you have the same file that I'm showing you. And it's in chapter 4, supplementary material. All right, so we're just going to begin with percentages, right? A percentage is just a ratio when the second quantity has been scaled to 100. That's it. That's all it is. You know what a percentage is. It actually came from two words, per and cent, meaning per 100. So that's what it means. That symbol contains two zeros and a line, just like 100, right? And we're going to do a little bit of financials with percentages. So the interest rate, the rate of return is just the interest rate associated with an investment. That's the rate of return, right? Investors want a high rate of return, a good interest rate. And an annuity, you might get one of these, perhaps, when you start working full time. And you just put money aside. You don't have to pay income tax on that money. And you withdraw the money and pay taxes when you retire, when your income is usually less than when you're working. Yeah, really, percentages are perhaps the most common type of ratio. We've already looked at them, right? The APR was an annual percentage rate, part per 100. 7% means 7% or $7 out of $100. So let's look at the rate of return on an annuity. So I'm going to switch over to the other ones that doesn't have the answers. Okay, so here is our traditional annuity. It has a 1-year return, 3, and a 5-year return. So we're going to use the 1-year rate and see how much our rate of return is and how much money we have left after 1 year. So assume a 1-year rate, the 1-year rate, which is 3.75%, calculate how much interest they will gain. Interest, by the way, from chapter 1 is dollars. So you have $100,000. I'm going to find out you want 3.75, and that's 3.75 over 100. I would actually put like that in my calculators. You start moving decimals, it becomes an issue sometimes. So that's going to be $3,750 in interest. So after 1 year, how much money they had after 1 year, they would have their original money that they put in plus $3,750. So after 1 year, that's how much money they had in their account. Now, the important thing is that the second year, they would still get the 3.75%, but they would get it on 103,000, not on 100,000, because they've already, that's what their thing is worth now. So you're talking about yearly compounded interest. So we're going to assume somebody starting out this date with $100,000. And we're going to do the 5-year, it's going to grow by a 5-year rate, which is up here. The 5-year rate is 3.98%. So they're going to get 3.98% interest. So 100,000 times 3.98 over 100 is 3,980. I did that in my head, so I didn't use a calculator. Their ending balance would be their principal plus their interest, which is 103,980. So that's what they would have after 1 year. Now, the beginning of the second year, they have exactly what they had at the end of the first year. This is where the compounding comes in. With dollars, right? And that's dollars. And that's dollars. So they're going to get this, which I will just see if I can copy that. They have that much money, and they're going to get 3.98%, which is 3.98 over 100, on this amount of money, the second year, which is, I did that on my calculator, 4138.40. So that's the interest that they earn the second year. Let's see if I can get that copied up there. And so at the end of the second year, they get 103,980 plus 4138.40. $108,118.40. All right, so I'm going to switch screens now, put in the answers here, and just discuss that just for a second. But you see how this is working, right? 100,000, 3.9% of 100,000, but you add the money at the end of the first year, and take a look at that. So here is what we have, all the answers filled in. So you notice that each year the money is going up because you earn the interest after the 1 year, then you have a new amount. Then you earn the interest after the second year, and you have a new amount. But I just want to take a look at how much this is going up. If it was going up by the same, say, I don't know, $180 or $150, this went up by 150, then it went up by 150 again, then it went up by 150 again, etc., it would be linear growth. So let's just take a look at that on our Excel file here. It's really a lot easier done on the Excel file. I just want 100,000 times that interest rate, which I want locked. And then I'm just going to add my 100,000 plus my interest, and then I start with that balance the second year. And so I think I can just drag this down, and I'm just reduplicating what I have in that other. And there we go. This is the same thing that other file is. What I want to look at is the change each year here. So I can't get the change the first year because that's where we start. So I'm going to get the change between here and here. So it's just going to be this minus this. And notice that this went up from here to here by $158. This went up from here to here by $164. Etc. So you notice that it's not a constant rate of change. This is an exponential function. It's an exponential rate of change because it's growing each year by a percentage of what it was the year before. So it's kind of the foundation of what exponentials are. And finally, in this chapter, in this section, I'm going to look at percentages and rewrite them as fractions and decimals. A lot of people try to memorize the rules about moving the decimal 2 places to the left or 2 places to the right. But when you get numbers that are less than 1%, like 75.75, you can do that, but like 0.75%, what is that as a decimal? And then it can lead to confusion. So I'm recommending that you just write 0.75% as 0.75 over 100, and then put in your calculator and make change. Just be really careful. So we're just going to do a few of these. This one's quite simple, right? 75% is the same thing as a fraction, 75 over 100, and it's the same thing as 0.75. So you can just go, basically, this one, put it in your calculator, and you're going to get that. See, now this is different. It's 0.75 over 100. What's that percentage? Well, that percentage is 0.75%. That's what it is. Whatever this is over 100, that's the percentage right there. Now, if you want to put it on your calculator, which I strongly recommend, you're going to get 0.0075. So this decimal is the same as this fraction, which is the same as this percentage. So I'm saying when fractions are less than 100, they can be tricky. Let's do a couple more. You have these in your book. Let's try this one. 7.5. Now 7.5 is 7.5 over 1. So to make it a percentage, you got to have a number over 100. So multiply 1 by 100, you'd have to multiply 7.5 by 100, and you're going to get 750. Which, that's the fraction. As the percentage, that's 750%. Yes, you can have 750% of some things. And let's try one more. How about this one? That is that. To change, think of it as an equivalent fraction. To change this to an equivalent fraction, I'm going to multiply both the numerator and the denominator by 100. And I'm going to get a number over 100. That's the fraction. It's a negative number, which means it's a negative percent. We're decreasing, and it's going to be, multiply this by 100 on your calculator, and you're going to get 0.23. And it's negative. Make it a little wider. That's the decimal, that's the fraction. The percentage is simply negative 0.23%. So I would look at the other ones in the book. They have the answers there.